All that energy of motion is converted to heat. This simple activity gives us life. I just want you to say these words. Say, ah.
Ah.
Okay, that's all you have to do is say, ah.
Ah.
Or, uh-huh. Let's try it.
Uh-huh.
Or, ah.
Ah.
Okay.
Uh-huh.
So I've got these two heavy ball bearings, and they're moving along, and they're going to hit each other because I'm going to have them collide. Okay. Now, do you think it takes a lot of energy to move this thing? It's pretty heavy.
Yeah.
It takes a little bit of energy, right? And it takes a little bit of energy to move this thing. They call that kinetic energy of motion, and they're going to come together right here. What happened to all that energy? Where did it go? As a matter of fact, there's a tremendous amount of energy involved.
Heat.
It was changed into heat energy. And to demonstrate that, I'm going to have you, Jesse, hold this piece of paper out for me. Just hold it right there like that. And I'm going to clack these things together right there on that piece of paper. Ready? 1, 2, 3. Tell me what you see.
A hole.
A hole. Hold that up so the camera can see.
It's burned. I can smell it.
You smell it? You smell it burnt?
Yeah.
Smell that. What does it smell like?
Smells burned.
It's burned.
You can even see a little bit of brown on
You
it.
can see a little brown. Do that again, right?
Ooh. Dang.
We found a new hole puncher.
A new hole puncher. Now smell that. Do you smell the burn all the way through there? Yeah. Oh yeah, you can smell it. It really smells burnt.
Just go up and down.
And you could do this at home probably with a couple of ball peen hammers or something.
Yeah.
Soft metal might not do it. You have to have some hardened steel, but you can bang them together and all that energy of motion is converted to heat. Now what's that got to do with anything? Well, in the morning when the sun comes up and it's throwing off all that light and heat energy that comes to the earth, you often might wonder, where's all that energy coming from? All that heat. And down at the center of the sun, all the molecules, atoms and molecules that make up the sun are colliding all the time.
No wonder it's a giant ball of fire.
Yeah, it's a giant ball of fire, all that heat. They're all going like this all the time. And gravity is pulling towards each other, and heat energy makes them go apart, and they're doing this all day long. Bam, 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 bam. That kind of motion. It's not ball bearings, obviously. You know, it's particles. But it's neat to know that that energy of motion that gravity causes, this simple activity gives us life. Of course, on the sun, it's at a nuclear level, and it's very powerful, and it burns more than paper. But this just gives you the idea. I wonder what happens if we put a piece of aluminum foil in there.
Ooh, that would be fun.
Oh, would you hold it? Oh, yeah. Look at that. What do you see?
It's not very warm.
It's not very warm.
It looks like someone tried to drill a hole, kind of.
Oh, that's weird.
That is weird, isn't it? Look at that. Little round holes.
A whole bunch of circles.
A whole bunch of concentric circles. Those are shock waves.
Oh.
Wow.
Oh, aluminum foil.
And that aluminum got hot enough, and there was a shock wave that got frozen in that aluminum. But the heat that generated made that. There was a shock wave. Isn't that sweet looking? Is this a good conductor of heat?
Yes.
Yeah. A paper a good conductor of heat?
No.
No. So the heat couldn't get away. So that's why it burnt the hole. Here, the heat could get away faster. Yeah.
That's why it's not very warm.
Well, yeah, right.